The year is 2024. Our planet is heating up, glaciers are melting, raising sea levels, wildfires rage across continents, fueled by drought and extreme heat. Cities choke under smog, millions struggle to breathe. The consequences of climate change are now our daily reality. Decades of burning fossil fuels have trapped heat, warming the planet. But what if, instead of just reducing emissions, we could engineer our way out? This is the radical proposition of geoengineering, technologies that aim to manipulate Earth's systems to counteract global warming. Could these interventions be our salvation or our downfall? Geoengineering sparks both excitement and trepidation. Proponents say it could buy us time to transition to cleaner energy. Imagine dimming the sun's rays or machines sucking carbon dioxide from the air. But manipulating Earth's systems raises profound ethical and political questions. Who decides which technologies to deploy, and what are the unforeseen consequences? The debate over geoengineering pits the urgency of the climate crisis against the unknown risks of intervention. Some warn it's a dangerous distraction from reducing emissions, while others insist research is crucial for informed decisions. This is a moral and scientific dilemma that will shape humanity's future. Join us as we explore the science, risks, and ethical dilemmas of geoengineering. Geoengineering is a bold attempt to reshape the systems that govern our planet. It encompasses a range of technologies aimed at mitigating climate change by deliberately altering Earth's climate system. Unlike traditional climate action, geoengineering tackles the symptoms of climate change directly. It's a high-stakes gamble, extraordinary measures for extraordinary times. One major category is solar radiation management, or SRM. SRM techniques aim to reduce solar radiation absorbed by Earth, effectively dimming the sun's rays. Ideas range from giant space mirrors to ships brightening clouds over the oceans. While SRM could cool the planet quickly, the risks of disrupting weather and ecosystems are significant. Carbon dioxide removal, or CDR, targets the root cause: excess atmospheric carbon dioxide. Imagine artificial trees or industrial facilities capturing carbon and converting it into useful products. CDR is less risky than SRM, but faces huge challenges in scalability and cost. Geoengineering isn't new. Scientists have explored it since the 1960s. Early ideas, from seeding oceans with iron to launching space mirrors, were often dismissed as science fiction. As climate urgency grows, so does interest in these bold proposals. Today, research is more cautious, emphasizing risk and the need for international governance. Geoengineering is moving from fiction to reality, with small-scale experiments underway. Researchers are testing stratospheric aerosol injection and marine cloud brightening. These experiments are vital for understanding risks, but they also raise ethical concerns about real-world impacts. Geoengineering offers hope, a potential lifeline as the planet warms. But it's a gamble with unknown consequences, as our understanding of Earth's systems is incomplete. It could help avert disaster or worsen the very problems it seeks to solve. The double-edged nature of geoengineering demands caution and humility. The climate crisis has pushed geoengineering into real-world experiments. These small, controlled trials provide crucial data, but highlight the ethical and environmental risks. Each experiment is a reminder of both human ingenuity and the high stakes of planetary intervention. Stratospheric aerosol injection, or SAI, is inspired by volcanic eruptions that cool the planet. Injecting aerosols could disrupt weather and damage the ozone layer. Projects like Harvard's SCOPEX are testing small-scale releases to study impacts. These experiments inform climate models but underscore the controversy of SAI. Marine cloud brightening, or MCB, aims to increase cloud reflectivity by spraying seawater into the air. Proponents see it as a reversible, low-cost way to cool the planet. Critics warn of potential disruptions to weather and ocean ecosystems. Field experiments are underway to assess both efficacy and risks. Ocean iron fertilization, or OIF, seeks to boost phytoplankton growth to absorb carbon dioxide. Results have been mixed, with concerns about ecological disruption and effectiveness. Due to risks, international regulations now restrict large-scale OIF experiments. Scaling up geoengineering from lab to planet is a massive challenge. What works in small trials may not translate globally, where feedback loops and surprises await. Governance and ethics loom large. Who decides and how are risks shared? The leap from experiment to deployment tests our wisdom as planetary stewards. The climate crisis adds moral urgency to the geoengineering debate. Who decides, who benefits, and who bears the risks? These questions demand robust governance and inclusive dialogue. The allure of geoengineering is undeniable. As the planet warms and the consequences of climate change become increasingly dire, the prospect of a technological solution, a quick fix to avert disaster, holds a powerful appeal. Proponents of geoengineering often point to the urgency of the climate crisis, arguing that we may not have the luxury of time to solely rely on reducing emissions, especially given the slow pace of political action and the inertia of global energy systems. Geoengineering, in this view, offers a way to buy us time, a stopgap measure to cool the planet while we transition to a more sustainable future. It's a seductive narrative, a technological deus ex machina that promises to solve a problem of our own making. But beneath the surface of this technological optimism lies a web of complexities and uncertainties that demand careful scrutiny. One of the most fundamental concerns surrounding geoengineering is, honestly, the inherent interconnectedness of Earth's climate system. The planet's atmosphere, oceans, and biosphere are all intricately linked in a delicate balance, and any attempt to manipulate one part of the system is likely to have ripple effects elsewhere. Geoengineering interventions, by their very nature, are likely to create winners and losers, altering weather patterns, rainfall distribution, and agricultural yields in ways that could benefit some regions while, unfortunately, harming others. For example, injecting aerosols into the stratosphere to reflect sunlight could disrupt monsoon patterns in Asia, potentially affecting the livelihoods of billions of people who depend on these seasonal rains for agriculture. The challenge, then, is not only to develop geoengineering technologies that work as intended, but to do so in a way that minimizes the risks of unintended consequences and avoids exacerbating existing inequalities. The history of human intervention in natural systems is, frankly, replete with examples of unintended consequences, often with unforeseen and detrimental effects. From the introduction of invasive species to the damming of rivers, our attempts to control or manipulate nature have often backfired, disrupting ecosystems, altering landscapes, and causing widespread ecological damage. Geoengineering, with its potential to alter Earth's climate system on a planetary scale, raises the stakes of unintended consequences to an unprecedented level. The sheer complexity of the climate system, with its intricate feedback loops and nonlinear dynamics, makes it virtually impossible to predict with certainty the full range of potential side effects from large-scale geoengineering interventions. What might seem like a minor tweak to one part of the system could, honestly, cascade through the interconnected web of atmospheric and oceanic processes, leading to unexpected and potentially catastrophic outcomes. The potential for geoengineering to be weaponized, whether intentionally or inadvertently, is a deeply unsettling prospect. The ability to manipulate weather patterns, even on a regional scale, could have profound geopolitical implications, potentially shifting the balance of power, exacerbating conflicts, and creating new vectors for aggression. Imagine a future where nations, driven by self-interest or fear, engage in a climate arms race, deploying geoengineering technologies to secure their own food and water supplies while disrupting those of their rivals. Or envision a scenario where a rogue state, desperate to avert the worst effects of climate change within its own borders, unilaterally deploys a geoengineering technology that triggers devastating droughts or floods in neighboring countries. The weaponization of weather is not merely a science fiction trope. It's a real and present danger that demands serious consideration as we grapple with the implications of geoengineering. The prospect of geoengineering raises profound questions about global governance and the need for international cooperation on an unprecedented scale. Who gets to decide whether, when, and how to deploy geoengineering technologies that could have planetary consequences? How do we ensure that the benefits and risks are distributed equitably, particularly for vulnerable populations who are often most affected by climate change but least equipped to influence decision-making processes? And how do we prevent the potential for unilateral action or geopolitical competition from undermining international efforts to address climate change responsibly? The development and potential deployment of geoengineering technologies demand a robust and enforceable global governance framework, one that ensures transparency, accountability, and equitable participation from all nations. Beyond the scientific and political challenges, geoengineering also presents a profound moral hazard. The very idea that we might be able to engineer our way out of climate change, to invent a technological solution to a problem rooted in unsustainable consumption and production patterns, risks creating a false sense of security, potentially undermining efforts to address the root causes of the climate crisis. If we believe that we have a technological safety net, a planetary reset button that we can push if things get too bad, we may be less inclined to make the difficult but necessary changes to our energy systems, our economies, and our lifestyles. The moral hazard of geoengineering is not that it might fail, but that it might succeed too well, providing a convenient excuse for inaction and perpetuating the very behaviors that have brought us to this precipice. The pursuit of geoengineering, therefore, must not distract us from the urgent task of transitioning to a more sustainable future, one that is less reliant on fossil fuels, more respectful of ecological limits, and more equitable in its distribution of benefits and burdens. Perhaps the most chilling scenario associated with geoengineering isn't its potential to go awry, but the terrifying prospect of what happens if we start, and then, for whatever reason, have to stop. Scientists warn of a phenomenon known as termination shock, a sudden and catastrophic spike in global temperatures if geoengineering interventions, particularly solar radiation management, are abruptly halted. Imagine a world where we've become reliant on a technological fix, a planetary sunshade that keeps the worst of global warming at bay. Now imagine that sunshade suddenly disappearing, either due to technical failure, political instability, or a global catastrophe that disrupts our ability to maintain it. The result would be a rapid and relentless warming, far exceeding the rate of natural climate change. This abrupt temperature surge, a climatic whiplash, would have devastating consequences for ecosystems, agriculture, and human civilization, making the very impacts we sought to avoid through geoengineering pale in comparison. The natural world, already reeling from the impacts of climate change, would face an unprecedented assault if geoengineering were to be abruptly halted. The rapid temperature rise associated with termination shock would outpace the ability of many species to adapt, leading to mass extinctions and ecosystem collapse on a global scale. Coral reefs, already bleached and dying from ocean acidification and warming, would face a death knell, their intricate structures dissolving in the increasingly acidic waters. Forests, already stressed by drought and wildfires, would succumb to widespread die-offs, releasing massive amounts of carbon dioxide back into the atmosphere and further accelerating warming. The intricate web of life that sustains our planet would unravel, with cascading failures rippling through ecosystems, disrupting food chains and threatening the very foundations of our biosphere. The consequences for biodiversity would be catastrophic, leaving a planet impoverished of its natural wonders and its capacity to support life as we know it. The human impact of termination shock would be equally devastating, triggering mass migrations and social unrest on a scale never before witnessed. Coastal communities, already grappling with rising sea levels, would face inundation and displacement as the oceans swelled at an accelerated pace, displacing hundreds of millions of people. Arid regions, already struggling with drought and desertification, would become increasingly uninhabitable, forcing mass exoduses in search of water and arable land. The competition for dwindling resources would exacerbate existing tensions, fueling conflicts over water rights, land access, and basic survival. The global order, already strained by inequality and geopolitical rivalries, would face unprecedented challenges as nations struggled to cope with the influx of climate migrants and the breakdown of social cohesion. The specter of climate-induced conflict, once a distant threat, would become a grim reality as nations and communities battled for survival in a world transformed by our own hand. The sudden and dramatic climate shifts brought on by termination shock would have devastating consequences for global food security. Agriculture, already facing challenges from climate change, would be pushed to the brink of collapse as temperature extremes, erratic rainfall, and the proliferation of pests and diseases wreaked havoc on crops and livestock. Bread baskets would turn to dust bowls, fisheries would collapse, and the delicate balance of global food systems would be thrown into disarray. Food prices would skyrocket, leading to widespread hunger, malnutrition, and social unrest. The most vulnerable populations, already struggling with poverty and food insecurity, would bear the brunt of this crisis, facing famine and displacement on an unprecedented scale. The very foundations of human civilization, built on the reliable production and distribution of food, would be shaken to their core, jeopardizing the well-being and survival of billions of people. The concept of termination shock, really raises some profound ethical questions about the long-term consequences of our actions and the intergenerational responsibilities we bear. If we embark on the path of geoengineering, knowing that it could create a dependency on technological interventions just to maintain a habitable planet, what obligation do we owe to future generations who will inherit this burden? Can we, in good conscience, alter the planet's climate system in ways that could have irreversible and potentially catastrophic consequences for those who come after us? The ethical dilemma of geoengineering is not only about balancing the potential benefits and risks in the present, but about considering the long-term implications for future generations who will inherit the consequences of our choices. It is a burden of responsibility that weighs heavily on the shoulders of those who advocate for geoengineering as a potential solution to the climate crisis. A sobering reminder that the decisions we make today will reverberate through time, shaping the fate of humanity and the planet for centuries to come. The very notion of geoengineering plunges us headlong into a moral minefield, forcing us to confront some really uncomfortable truths about our relationship with the natural world and the limits of human control. Can we, even as we grapple with the consequences of our past actions, claim the right to reshape Earth's climate system according to our own designs? Do we possess the wisdom to foresee the full ramifications of such audacious interventions? To predict with any certainty the cascading effects that our actions might unleash upon the delicate balance of our planet? These questions strike right at the heart of our moral compass, challenging us to define the boundaries of responsible innovation in an age of unprecedented technological power. As we stand at this crossroads, the weight of generations yet to come bears down upon us, their fate intertwined with the choices we make today. One of the most potent criticisms leveled against geoengineering is that it could serve as a dangerous distraction. a sort of technological sleight of hand that allows us to evade our collective responsibility for addressing the root causes of climate change. By offering the tantalizing possibility of a quick fix, a planetary reset button, geoengineering risks becoming a convenient excuse for inaction, a way for governments and corporations to continue with business as usual while deferring the difficult choices required to transition to a truly sustainable future. The danger lies in allowing the promise of geoengineering to lull us into a false sense of security, to believe that we can continue our unsustainable consumption and production patterns without consequence. The true test of our commitment to addressing climate change lies not in our ability to manipulate the planet, but in our willingness to transform our own behavior, to embrace a future where our relationship with the natural world is one of respect, responsibility, and restraint. The debate over geoengineering is not merely a scientific or technological one. It is fundamentally a question of values, ethics, and global justice. Who gets to decide whether, when, and how these powerful technologies are deployed? Whose voices are heard, and whose interests are served in the halls of power where these decisions are made? The potential for geoengineering to exacerbate existing inequalities is a matter of profound concern. Developing countries, often on the front lines of climate change impacts, may lack the resources or influence to shape the geoengineering agenda, potentially leaving them vulnerable to decisions made elsewhere that could have devastating consequences for their people and ecosystems. Ensuring that geoengineering research and any potential deployment are guided by principles of equity, justice, and respect for the sovereignty of all nations is not merely a matter of fairness, but a fundamental prerequisite for building a sustainable and just future for all. As geoengineering moves from the fringes of scientific inquiry into the realm of real-world experiments and policy debates, a chorus of dissent is rising from communities around the globe. Indigenous peoples whose traditional knowledge systems and deep connections to the land have been marginalized for centuries are raising their voices in caution, warning against the hubris of assuming that we can control the delicate balance of nature without consequence. Environmental justice advocates, acutely aware of the potential for geoengineering to exacerbate existing inequalities, are demanding a seat at the table, insisting that any decisions about deploying these technologies must be made with the full participation and consent of those most likely to be affected. From the streets of major cities to remote villages on the front lines of climate change, a global movement is taking shape, demanding transparency, accountability, and a more just and equitable approach to addressing the climate crisis. These voices of dissent, often marginalized in the halls of power, are a powerful reminder that the future of our planet is not a matter for scientists and policymakers alone to decide, but a shared responsibility that demands the wisdom, courage, and active participation of us all. As we stand on the precipice of a geoengineered future, a profound question reverberates through the halls of science, the chambers of government, and the hearts of individuals worldwide. What path will humanity choose? Will we, in a desperate bid to avert the worst consequences of our own unsustainable actions, seize the reins of Earth's climate system, assuming the mantle of planetary engineers? Or will we heed the cautionary tales woven into the fabric of history, stories of unintended consequences, and the hubris of believing we can control the intricate dance of nature? The choice before us is not merely a technical one, a calculation of risks and benefits. It is a reflection of our values, our aspirations, and our vision for the future of humanity and the planet we call home. It is a choice that demands careful consideration, open dialogue, and a deep understanding of the profound implications, both intended and unforeseen, of tampering with the very systems that sustain life on Earth. If we are to navigate the treacherous waters of geoengineering responsibly, international cooperation is not merely desirable, it is essential. The very nature of these technologies, with their potential for planetary-scale impacts, transcends national borders and honestly demands a level of global governance and coordination unlike anything we have seen before. A fragmented approach, driven by national self-interest or the ambitions of a few powerful nations, risks triggering a cascade of unintended consequences, exacerbating existing inequalities, and potentially pushing the planet further down a path of ecological instability. What is needed is a robust and enforceable international framework, one that establishes clear guidelines for geoengineering research, experimentation, and potential deployment. This framework must be founded on principles of transparency, accountability, and equitable participation, ensuring that all nations, regardless of their size or economic might, have a voice in shaping the future of our planet. The future of geoengineering cannot be dictated by a select few behind closed doors. It must be shaped by an informed and engaged global citizenry. The decisions we make today about whether, when, and how to deploy these powerful technologies will have profound and lasting consequences for generations to come. It is therefore imperative that we democratize access to knowledge about geoengineering, fostering open and transparent dialogue that transcends the confines of academia, government, and corporate boardrooms. We need to move beyond the technical jargon and scientific debates, making the science of geoengineering accessible to all, empowering communities to ask critical questions, voice their concerns, and participate meaningfully in shaping a future that affects us all. The knowledge we gain from geoengineering research must be treated as a public good, freely shared and openly debated, so that we can make informed and collective decisions about the future of our planet. The challenges posed by climate change are complex and multifaceted, demanding innovative solutions and a willingness to challenge conventional thinking. Geoengineering, for all its potential risks and uncertainties, represents one such challenge, a stark reminder of the extraordinary measures we may need to take to preserve a habitable planet for future generations. Yet the decision of whether or not to embark on this path, to assume the mantle of planetary engineers, is not one that can be made lightly or in isolation. It demands a global conversation, a collective act of reflection and deliberation that transcends disciplinary boundaries, cultural differences, and political ideologies. The future of geoengineering, and indeed the future of our planet, hinges on our ability to engage in open, honest, and respectful dialogue, to listen to diverse perspectives, to acknowledge uncertainties, and to work together towards a future where humanity and nature can thrive in harmony. Throughout this exploration of geoengineering, we have journeyed to the very edge of human ingenuity, peering into a future where the fate of our planet lies perhaps in our own hands. We've grappled with the science, the politics, the ethics, and the sheer audacity of seeking to manage Earth's climate. What began as a simple question, can we control Earth's climate, has unfurled into a tapestry of complexities, each thread a testament to the interconnectedness of our world. We've seen how the allure of a quick fix, a technological shield against the storm, can be both tempting and perilous. The seductive promise of geoengineering, its potential to avert disaster and buy us time, must be weighed against the profound risks it carries. Unintended consequences that could ripple through ecosystems, exacerbate inequalities, and even ignite geopolitical conflicts. Yet, within these very dilemmas lies an opportunity, a chance to reevaluate our place in the web of life. The debate over geoengineering is not just about which technologies to pursue, or how, but why. It forces us to confront the ethics of manipulating nature on a grand scale, to ask whether our role should be that of a caretaker or a conqueror. The answers are far from simple, often lying in the uncomfortable space between scientific certainty and moral conviction. But the very act of asking these questions is a testament to our capacity for reflection, our willingness to learn from past mistakes, and our enduring hope for a future where humanity and nature can coexist in a more harmonious balance. The future of geoengineering is not preordained. It is a story yet unwritten, its chapters filled with both promise and peril. The choices we make today, individually and collectively, will determine the course of this story, shaping the world we leave behind for generations to come. If we proceed down this path, it must be with a deep sense of humility, a recognition that we are tinkering with systems far more complex than we fully comprehend. International cooperation, grounded in transparency and guided by ethical principles, is paramount. We need a global framework, one that transcends national self-interest and embraces the interconnectedness of our challenges. Yet, our efforts cannot end there. Addressing the root causes of climate change, our unsustainable consumption patterns, our reliance on fossil fuels, our disregard for the natural world, remains paramount. Geoengineering, at best, can only ever be a temporary bridge, a stopgap measure to buy us time while we undertake the monumental task of transforming our relationship with our planet. The question is not simply, can we control Earth's climate, but rather, how will we choose to shape our future? Will we strive to be wise stewards, guided by a deep respect for the delicate balance of nature? Or will we succumb to the allure of technological dominance, risking unforeseen consequences for generations to come? The answer ultimately lies within each of us. The future of our planet is not a matter of fate, but a reflection of the choices we make today.